Hello everyone, so for today we're going to answer 3 physics problems that we got in the University Physics book, and we're in chapter 15, which is all about mechanical waves. So let's get started. For the first problem, it is all about energy in wave motion. So the problem goes: a horizontal wire is stretched with a tension of 87 newtons, and the speed of transverse waves for the wire is 492 meters per second squared. What must the amplitude of a traveling wave of frequency 61.0 Hz be for the average carried power by the wave to be 0.358 watts? So in this equation, we are asked to get the amplitude of the traveling wave of frequency. So first things first, we need to identify the given. So we are given F, the force or the tension, which is 87 newtons. We have given a V, which is 492 meters per second, a frequency of 61 hertz, and a P average of 0.358. So the equations that we're going to use is the most important is the wave power, which is the average power carried by the sinusoidal wave. So the next one is V is equal to square root of F over mu, which is the wave speed in terms of tension and linear mass density. While for the last equation, which is omega is equal to 2 pi f, which is the relation between the angular speed of the wave and the frequency. So excuse me, first is we need to find the omega, since we need we need to find first the things that we are going to use, or the things that we're going to plug in the wave power equation. So first is omega, which is 2 pi frequency. Since we're given the value of the frequency, we're just going to plug it in. 2 pi times the frequency, which is 61 hertz. We're going to have an answer of 383.27. For the next one is mu. So we have an equation of V is equal to square root of F over mu, which is the wave speed in terms of tension and mass per unit length. So since we need mu, we're just going to rearrange the equation, and we're going to arrive at an equation of F over V squared. So since we're given F, which is 87 newtons, over V, which is we also given, plug it in, and we're going to arrive at an answer. Mu is equal to 3.59 times 10 raised to negative 4 kilogram per meter. So after that, we're just going to input all of them into the wave power equation. But since we are looking for the amplitude, we are going to isolate the amplitude so that we are going to have the right equation. So plug in all the given. This one also given 1/2 square root of this one times this, and we're going to arrive at an answer, which is the amplitude, which is 4.09 times 10 raised to negative 3 meters. For our next problem, it is all about the speed of transverse waves. So, with what tension must a rope with length 2.70 meters and mass of 0.145 kilograms be stretched for transverse waves of frequency 45 Hz to have a wavelength of 0.770 meters? So we must identify the given, which is a length of 2.70 meters, a mass of 0.145 kilograms, a frequency of 45 hertz, and lambda 0.770, which is given, which is the wavelength. So the equation that we're going to use is the wave string speed in terms of tension and mass per unit, and the wave speed in terms of wavelength and frequency, which is this one. So okay, we're just going to plug in the things that we have. So first we're going to use the wave speed in terms of wavelength and frequency. So V is equal to F times lambda. F is equal to 45 Hertz, while lambda is 0.770 meters. And we're going to arrive at an answer of 34.65 meters per second. And then we're going to look for mu, and we're going to use the equation mass over length, and we're given the value of 0.145 for mass and the length of 2.70. So we're just going to divide this one and this one, and we're going to arrive at an answer of 0.0537 kilogram per meter. And then since we need to find the actually this one is the linear density of the rope. So we're just going to go back to the question. We need to find the tension or the force of the we're going to find the we're just going to go back, and in this problem we need to find the tension of the rope. So okay, going back again, since we have this equation, we're just going to isolate F in order, since we have the value of this one V and mu. So in order to find the tension force, we must isolate F, and then we're going to have an equation of V times mu, and we're just going to plug in all the values that we have, and we have computed. So 0.0537 kilograms per meter times 34.65 meters per second. This one's squared. So we're going to have an answer of the tension and it will be 64.47 newtons. So for our last problem, it is all about the normal modes on a string. So the problem is, one string of a certain musical instrument is 80 centimeters long and has a mass of 8.71 grams. It is being played in a room where the speed of sound is 344 meters per second. So to what tension must you adjust the string so that when vibrating in its second overtone, it produces a sound of wavelength 0.52 meters? What frequency does this string produce in its fundamental mode of vibration? So, in this problem, we need to find the tension wherein it will produce a wavelength of 0.752 in the second overtone. And we also need to find the frequency the frequency that it will produce in its fundamental mode of vibration. So the given that we have is the length, which is 80 centimeters. We're just going to convert it into meters, and we're going to have 0.80 meters. And then the mass is given also, but in grams, so we need to convert it to kilograms, and we will have 0.00871 kilograms. And V, which is 344 meters per second, and lambda, or the wavelength, which is 0.52 meters. So the first thing we need to do is to calculate for the linear density, which is mass over length, and plug it in the given that we have for the mass and the length. We're going to have an answer of the linear density, which is 0.0109 kilogram per meter. The next one is we need to compute for the wavelength in the second overtone or the third harmonic. So we have an equation of lambda n is equal to 2L over n, which n is the to since we have a third harmonic, we're just going to use 3 since we're asked to look for the third harmonic. So excuse me. So we have an equation of lambda 3 is equal to 2L over 3. And then L is the length, so we have its value also. And then plug it in and perform the indicated operations. And we're going to arrive at an answer of 0.53 meters. And then we're going to calculate the frequency in the third harmonic or in the second overtone. And then the equation for us to find the frequency is the propagation speed over its length or over its wavelength. So plug in the values that we have, 344 meter per second, wherein it is the speed of propagation over the wavelength, which is 0.752 meters, and we're going to have an answer of 457.45 hertz for our frequency. And then in order for us to find the velocity, velocity is equal to lambda or the wavelength times the frequency. Since we have both of the values that we need, plug it in and we're going to arrive at an answer of 242.45 meters per second. And then in order for us to find the tension force, we're going to use the wave string speed in terms of its tension and its mass per unit length, or the mu. So we're going to use this equation and then we're just going to rearrange it, and then F is equal to V squared mu. So plug in the values that we have and we're going to arrive at an answer of 640.72 newtons. And then for letter B, since we have calculated this earlier, and then we need to find the frequency of the third harmonic, so this one perform, and then we're going to arrive at 152.48.